September 19th, 1944. The fog-shrouded fields near Aracourt, France. Obergefreiter Klaus Behrens gripped the edges of his Panther tank's cupola, scanning the mist that clung to the rolling terrain like a burial shroud. His crew had been told the truth, repeated in every briefing since July. The American Sherman posed no serious threat to Panther frontal armor. The mathematics were simple, reassuring. The Sherman's 76mm gun, even the improved version, could not penetrate the Panther's glacis plate. Not at any range. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. What Behrens and thousands of German tankers advancing that morning did not know was that tucked into the ammunition racks of selected American Shermans were rounds that would fundamentally alter this tactical certainty. 6 M93 high-velocity armor-piercing rounds per tank, each containing a tungsten carbide core capable of punching through a Panther's turret mantlet at 1,000 yards. Not point-blank range. Not the suicidal 100 meters German intelligence had calculated. 1,000 yards. The psychological impact of this ammunition would prove as devastating as its penetrating power. German crews, who had fought confidently behind armor they believed invulnerable, would learn, in the span of a single engagement, that American tanks could kill Panthers frontally at ranges previously considered safe. The story of how American industry and metallurgy created this capability and how its battlefield deployment shattered German tactical assumptions begins not in the fog-shrouded fields of Lorraine, but in the testing grounds and industrial facilities of the United States, where engineers worked against time to solve a problem that threatened American armored operations across Europe. In early 1944, the United States Army faced a crisis that military planners had catastrophically misjudged. The M4 Sherman tank, the backbone of American armored divisions, was encountering German tanks it could not reliably defeat from the front. The Panther, Germany's answer to the Soviet T-34, combined a powerful 75mm high-velocity gun with an 80mm glacis plate sloped at 55 degrees, creating an effective thickness of approximately 140mm that proved nearly impenetrable to standard American tank guns. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. American intelligence had fundamentally underestimated both the quantity and quality of Panthers that would be deployed in France. By June 1944, when Allied forces landed in Normandy, 38% of German tanks in the theatre were Panthers. Not the handful predicted in pre-invasion assessments, but hundreds of these advanced medium tanks, often crewed by inexperienced soldiers, but protected by armor that conventional American tank guns simply could not penetrate frontally. The 75mm M3 gun that armed most Shermans landing in Normandy could not penetrate a Panther's frontal armor at any practical combat range. The armor-piercing round would simply ricochet off the sloped glacis plate, leaving the Sherman crew exposed to return fire from the Panther's powerful gun, which could destroy a Sherman from ranges exceeding 2,000 meters. Even the improved 76mm M1 gun, which began reaching frontline units in July 1944, struggled desperately against Panther armor. Using standard M62 armor-piercing capped rounds, the 76mm gun could penetrate 109mm of armor at 1,000 meters when striking at 0 degrees obliquity. This proved sufficient against the Panzer IV and many German assault guns, but the Panther's sloped frontal armor remained effectively immune. The 76mm could theoretically penetrate the Panther's gun mantlet, but only at extremely close range, typically under 100 meters, a distance at which the Panther's advantages in firepower made engagement suicidal for Sherman crews. The problem was not fundamentally the gun itself, but the ammunition it fired. The standard armor-piercing rounds lacked the penetrating power needed to defeat modern German armor at combat ranges. The deployment of the 76mm gun itself had been a saga of bureaucratic hesitation and tragically belated recognition of battlefield realities. The first M4 Shermans mounting the 76mm M1 gun rolled off American production lines in January 1944. These M4A176 Shermans arrived in Britain on April 10, 1944, with 130 tanks delivered specifically to prepare for the Normandy invasion. Yet, despite their availability, American commanders refused to deploy these improved tanks on D-Day. The reasons were multiple and, in retrospect, catastrophic in their short-sightedness. Crews lacked adequate training time on the new weapon system. Logistical concerns about maintaining two different ammunition types complicated already strained supply planning. Most critically, commanders believed the 75mm gun would prove adequate for the expected opposition. This assumption, based on incomplete intelligence about German armoured strength in France, proved to be a devastating miscalculation that would cost American lives and tanks throughout the Normandy campaign. By early July 1944, field reports from Normandy painted an increasingly grim picture. On July 2nd, urgent complaints about the 75mm gun's ineffectiveness against German armour reached General Dwight Eisenhower himself. His response, documented in multiple historical accounts and witnessed by staff officers, captured command-level frustration with a problem that should have been foreseen and addressed months earlier. "You mean our 76 won't knock these Panthers out? Why, I thought it was going to be the wonder gun of the war." The full exchange, as recorded by witnesses present at the meeting, and continued with considerably stronger language as Eisenhower expressed his anger that ordnance officials had assured him the 76mm would take care of anything the Germans had fielded. The reality confronting American tank crews in the hedgerows of Normandy told a very different story. A board convened on July 12, 1944, to investigate the armour penetration crisis, determined officially what tank crews already knew from bitter experience gained at terrible cost. Standard American tank weapons could not defeat Panthers frontally at any practical combat range. The Panthers' combination of armour protection and firepower had created a tactical imbalance that threatened American armoured operations. General Omar Bradley immediately ordered the 76mm Shermans rushed from their storage positions in Britain directly to the front lines in France. On July 25, 1944, during Operation Cobra, the long-planned breakout from the Normandy beachhead, 102 M4A176 tanks made their combat debut. The initial engagement reports proved sobering rather than encouraging. While the 76mm represented a meaningful improvement over the 75mm gun, it still struggled against Panther frontal armour at practical combat ranges. Sherman crews quickly learned through harsh experience that they needed to manoeuvre for dangerous flank shots or attempt to target the Panther's gun mantlet at close range. Neither tactical option proved desirable when facing a tank that could destroy them from 2,000 meters away with its first shot. The solution to this tactical crisis lay not in bigger guns or thicker armour, but in metallurgy and physics. By July 1944, American ordnance engineers at the Aberdeen Proving Ground had developed the T4 round, later standardized as the M93 HVAP. High-velocity armor-piercing ammunition represented a fundamental departure from conventional armor-piercing projectile design, applying principles of materials science and ballistics that would transform the tactical balance of armored warfare. The M93 projectile consisted of a tungsten carbide core, one of the hardest materials then available to industry, surrounded by a lightweight aluminum body and ballistic windshield. This revolutionary design concentrated the projectile's kinetic energy into a much smaller, dramatically denser penetrator, while simultaneously reducing overall weight. The ballistic advantages were significant and immediately apparent in testing. The M93 round achieved a muzzle velocity of 1,036 meters per second compared to 792 meters per second for the standard M62 round. This 244 meters per second velocity increase translated directly and dramatically into penetrating power. At 1,000 yards, approximately 914 meters, the HVAP round could penetrate 160 millimeters of armor at 10 degrees obliquity, according to official War Department testing data conducted throughout late summer 1944. Against the Panther's gun mantlet, with its curved 100mm thick cast steel construction on early AUSF D and A variants, later increased to 120mm on the AUSF-G. This meant reliable penetration at ranges up to 1,000 meters instead of the suicidal point-blank distances previously required. The mantlet suddenly transformed from a small, vulnerable area, requiring desperate close-range shots, into a viable target for Sherman crews at combat ranges, where both tanks had reasonable chances of hitting their targets. This fundamental shift in tactical engagement ranges would prove psychologically devastating to German crews who had grown confident in their armor's protective capabilities. But the development of HVAP rounds represented only half the solution to the penetration problem. Production at industrial scale was an entirely different challenge, with its own constraints and complications. The T4 round depended absolutely on tungsten carbide, a strategic material imported primarily from China, which produced 36% of global tungsten supply before the outbreak of war in Europe. Tungsten was critical to numerous war industries, competing desperately for limited supplies. Machine tools, armor-piercing ammunition for multiple calibers of weapons, armor plate hardening, and various industrial processes all competed for the same constrained tungsten supplies. American tungsten demand for HVAP ammunition alone consumed hundreds of metric tons annually. Each 76mm HVAP round contained approximately 0.88 kilograms of tungsten carbide, meaning a single Sherman carrying the standard load of 6 HVAP rounds required nearly 5 kilograms of this precious, strategically vital material. Multiply this by thousands of tanks and tank destroyers across multiple theaters of operations, and the industrial challenge becomes immediately apparent. China produced approximately 10,000 metric tons of tungsten concentrates in 1944, but this limited supply had to serve all Allied needs across all applications in every theater of the global war. The United States supplemented Chinese imports with domestic production from limited deposits in Colorado, Nevada, and California, but total availability remained severely constrained throughout the war. Germany's tungsten position was considerably worse, with Swedish imports declining sharply as the war turned decisively against the Reich and domestic production remaining minimal, despite desperate efforts to increase output. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. By 1945, German factories desperately hoarded their remaining tungsten stocks for machine tools needed for aircraft engine production, while Panther crews advancing into combat received only standard ammunition without access to tungsten core rounds. The United States Ordnance Department had been testing HVAP projectiles in various forms since spring 1942, but production at meaningful scale did not begin until after the Normandy landings revealed the full extent of the Panther problem to senior commanders. The first 1,000 rounds of 76mm T4 produced in July 1944 were sent by air transport to the European theatre of operations, specifically for the ICIGNI tests scheduled for August 20th. These tests would validate the round's penetration capabilities against actual captured German armor under controlled conditions. The portion that remained after comprehensive testing was immediately issued to troops in direct contact with German armor. A second shipment of 1,000 3-inch T4 rounds, compatible with the M10 tank destroyer's main gun, was also shipped by air in August. But after these initial emergency air shipments, the rest of production came by normal surface shipping, which required approximately 10 weeks transit time from American ports to frontline units in France. After August 1944, the receipt of HVAP rounds for both the 3-inch and 76mm guns through the end of the campaign in the European theatre remained constrained by production capacity and shipping availability. It was not until mid-January 1945 that HVAP rounds received in the European theatre exceeded 2,000 per week, a rate that still left most tank battalions chronically short of this critical ammunition. Priority for the limited HVAP ammunition initially went to M18 Hellcat tank destroyer units, whose doctrinal mission explicitly centered on destroying enemy armor. Tank battalions received whatever remained after tank destroyer units were supplied. It was only in 1945, after the heavy tank losses of the Battle of the Bulge demonstrated the continuing vulnerability of American armor, that tank units received enough HVAP ammunition to carry the often quoted allocation of 2 or 3 rounds per tank. Most Sherman crews in France during autumn 1944 fought with either no HVAP rounds or at most 1 or 2 precious rounds carefully rationed for desperate situations. September 19, 1944. The morning fog at Aracourt created visibility conditions that would prove both advantage and curse for the opposing forces. Colonel Bruce Clark's Combat Command A of the 4th Armoured Division held a thinly stretched defensive position around the town, covering far more territory than its strength truly warranted. The 37th Tank Battalion under Lieutenant Colonel Creighton Abrams formed the core of Clark's defensive line, but 1/3 of the combat command's strength had been detached the previous day to aid the desperate fight for Luneville to the south. German 5th Panzer Army, commanded by General Hasso von Manteuffel, had assembled 262 tanks and assault guns for a coordinated offensive intended to recapture Luneville and eliminate the American bridgehead over the Moselle River. The German force initially comprised the 11th Panzer Division, along with the newly formed 111th and 113th Panzer Brigades. German planners anticipated quick defeat of the undermanned American forces based on their local superiority in troops and armor. What German intelligence had failed to account for was superior American use of terrain, better tactical deployment, overwhelmingly effective artillery support, and the recent arrival of limited quantities of M93 HVAP ammunition to selected American units. At 7:45 in the morning, Captain William Dwight, serving as liaison officer between Combat Command A and the 37th Tank Battalion, was driving his jeep between the 2 command posts when he spotted a rumbling column of German tanks approaching from the town of Moncourt through the dissipating morning fog. He immediately returned to Combat Command A headquarters and reported what he had observed. Colonel Clark instantly recognized how perilous his situation had become. He had minimal forces positioned to stop a determined German armoured assault aimed directly at his headquarters position. Clark immediately ordered Captain Thomas Evans to move his tank destroyer platoon from Charlie Company, 704th Tank Destroyer Battalion, to establish a blocking position on Hill 246, approximately 800 yards from the village of Rechicourt-la-Petite. At 7:45 in the morning, Captain Dwight, accompanied by 4 M18 Hellcat tank destroyers under Lieutenant Edwin Leiper, reached the summit of Hill 246. The crews had barely assumed firing positions when they observed a single German tank emerge from the woods at the base of the hill, followed rapidly by additional vehicles. The lead tank destroyer, commanded by Sergeant Stacy, opened fire with its 3-inch gun, striking the enemy tank with its first shot. More German tanks became visible through the fog, and Stacy destroyed a second target in quick succession before a German round struck his Hellcat, injuring the crew but leaving the vehicle mobile enough to withdraw under its own power back toward Aracourt. The engagement at Hill 246 marked only the opening phase of what would become an 11-day battle testing American and German armoured doctrine under conditions neither side had fully anticipated. German tanks advanced throughout the morning in multiple columns, attempting to overwhelm American positions through weight of numbers and the presumed superiority of Panther armour. American forces responded with combined arms tactics, using artillery, tank destroyers, and carefully positioned Sherman tanks to create devastating crossfires that negated German armour advantages. Captain Jimmy Leach commanded Baker Company of the 37th Tank Battalion. His company had been positioned at Chambray, several kilometres north of Aracourt, when Colonel Clark's urgent summons arrived. Leach, believing the message indicated routine repositioning, preceded his company to Clark's command post. He found an exasperated Clark demanding to know where the hell his company was, while German tanks were already being engaged by division artillery at ranges measured in hundreds of meters from the command post itself. Within minutes, Leach's company arrived and deployed rapidly into defensive positions south of the Aracourt-Rechicourt road. 3rd Platoon, commanded by Staff Sergeant Louis Marston, engaged the advancing German column first. The Panthers, advancing through terrain they had not properly reconnoitred, found themselves exposed on open ground against hull-down American tanks that had selected their firing positions with care. Marston's platoon opened fire, and several German tanks immediately began maneuvering to seek cover. Then, 2nd Platoon under Staff Sergeant James Bereze passed through Marston's position, moving to establish a blocking position that would prevent the German column from bypassing the American defensive line. As Leach later recalled in interviews conducted for documentary purposes, the German tanks abandoned their assault with remarkable speed once they encountered coordinated American fire. They put those things in high gear, those Panther tanks, and they took off over a hill and disappeared beyond a big hill on the right. For several hours, these two platoons maintained their blocking positions until Major William Hunter, executive officer of the 37th Tank Battalion, arrived with the remainder of Baker Company and 2 platoons from Able Company. These forces formed an improvised task force under Hunter's command with the mission to intercept and destroy another German column that intelligence indicated was approaching from the south. The fog that had initially concealed German movements now served American defenders, allowing Sherman tanks to maneuver without being observed by German forces at longer ranges. The tactical situation throughout September 19th revealed patterns that would characterize the entire Aracourt battle. German forces possessed local numerical superiority and technically superior individual tanks. American forces held advantages in terrain utilization, artillery support, tactical coordination, and increasingly, specialized ammunition that German intelligence had not accounted for in their operational planning. The psychological dimension of this ammunition's effectiveness would prove as significant as its material penetrating power. German tankers advancing that morning had been trained extensively on Panther capabilities and limitations. They understood their tanks' strengths: superior frontal armor, excellent main gun, reasonable mobility despite the Panther's 45-ton weight. They also understood acknowledged vulnerabilities: thin side armor, requiring constant attention to flank security, mechanical reliability issues that demanded skilled drivers, final drive assemblies prone to failure under hard use. What they had not been briefed on, because German intelligence did not yet know, was that American 76mm guns now had access to ammunition capable of frontally defeating Panther armor at ranges previously considered safe. The Panther's armor scheme had been designed specifically to defeat known Allied anti-tank weapons. The 80mm glacis plate sloped at 55 degrees, created effective thickness of approximately 140 millimeters against projectiles striking from directly ahead. Standard American 76mm armor-piercing rounds could not penetrate this protection. German testing of captured American ammunition had confirmed this comfortable fact. The turret mantlet, though only 100 millimeters thick on most variants, presented a curved surface that increased effective thickness and often caused projectiles to ricochet. German crews had been taught that American tanks needed to close to point-blank range, typically under 100 meters, to reliably penetrate the mantlet. At such close ranges, the Panther's superior gun gave German crews multiple advantages. This tactical certainty, reinforced through training and confirmed by early combat experience in Normandy, shaped German crew psychology and tactical decision-making. Panther commanders felt confident engaging Sherman tanks at ranges exceeding 1,000 meters, knowing their frontal armor provided protection while their gun could destroy American tanks with first-shot hits. This confidence translated into tactical aggressiveness, willingness to advance across open terrain, and relatively casual attention to cover and concealment when Shermans were the primary opposition. September 19th would begin teaching German tankers a different lesson. At Aracourt, American artillery forward observers had established excellent observation positions that provided clear fields of view across the gently rolling terrain. When German armor appeared, American artillery battalions immediately began engaging with time on target fires that saturated German assembly areas and approach routes. The 191st Field Artillery Battalion, equipped with 155mm howitzers, proved particularly effective. These heavy guns, firing high explosive rounds at ranges around 1,000 yards using direct fire over open sights, destroyed or disabled multiple German tanks that attempted to approach the American command post. The German 113th Panzer Brigade had advanced in multiple columns without adequate reconnaissance. a failure that would prove costly. 5th Panzer Army lacked integral scouting units due to organizational decisions made earlier in the war. This meant German tanks advanced blindly into terrain the Americans had already surveyed, mapped, and prepared for defense. The thick morning fog that should have concealed German movements instead created confusion in German formations, while American forces, already positioned in prepared locations, could orient themselves using local landmarks and pre-planned firing positions. By early afternoon on September 19th, the initial German assault had been decisively repulsed with heavy losses. Colonel Clark ordered a counterattack to exploit German disorganization. A combined force from Companies A and B of the 37th Tank Battalion, led by Major Hunter, wheeled south through Rechicourt, caught the withdrawing German column in the flank, and knocked out 9 Panthers with the loss of only 3 American tanks. This kill-loss ratio, heavily favorable to American forces despite the Panthers' theoretical superiority, reflected multiple American advantages: better tactics, superior artillery support, effective use of terrain, and increasingly, the availability of specialized ammunition that German crews had not anticipated. As the day ended, the 37th Tank Battalion turned its attention to clearing remaining German infantry west of Moncourt. Guided through the night by the flames of burning German tanks that marked the day's killing ground, American forces assembled in the vicinity of Les, preparing for operations the following day. The German armoured attack appeared to have exhausted itself against American defences that proved far more formidable than 5th Panzer Army planners had anticipated. General George Patton, commanding 3rd Army, travelled from his headquarters at Étain to Aracourt on September 19th to personally assess the situation. After consulting with Major General John Wood, commander of 4th Armoured Division, Patton agreed that Combat Command A should begin advancing towards Sarreguemines the next morning, reinforced by Combat Command Reserve, which had arrived from Lunéville during the day. The German offensive appeared broken, creating opportunities for renewed American advances toward the German border and the strategic Saar Basin beyond. But German commanders, though shaken by the day's losses, had not abandoned their offensive objectives. Throughout September 20th, 21st, and subsequent days, German forces would launch repeated attacks, attempting to overwhelm American positions through sustained pressure. These attacks would provide American crews with multiple opportunities to employ their specialized ammunition against Panthers at ranges that shocked German tankers, who believed themselves protected by superior armor. The psychological impact of HVAP ammunition extended far beyond its actual battlefield employment. Most American tanks at Aracourt carried no HVAP rounds at all. Those that did typically had only 1 or 2 precious rounds, carefully saved for situations where standard ammunition proved inadequate. But the mere fact that some Shermans could frontally penetrate Panthers at extended ranges fundamentally altered German tactical calculations. Panther crews who had previously advanced confidently became more cautious, more attentive to cover, less willing to expose their tanks unnecessarily. This psychological shift degraded German offensive effectiveness, even in engagements where no HVAP rounds were actually fired. The development of the M93 HVAP round represented the convergence of multiple factors: American industrial capacity to produce specialized materials in meaningful quantities, scientific understanding of ballistics and penetration mechanics, recognition of tactical problems based on frontline reports, and willingness to commit strategic resources to solving immediate combat challenges. Germany possessed comparable scientific knowledge and understood the principles of tungsten core ammunition. German engineers had developed functionally similar designs. The critical difference came down to industrial capacity and resource availability rather than scientific sophistication. American industry could produce HVAP rounds in quantities sufficient to influence battlefield outcomes, though never enough to fully equip all units as commanders desired. German industry, by autumn 1944, could barely produce enough tungsten core ammunition to conduct testing, let alone supply frontline units. This pattern repeated across numerous weapon systems throughout the war. Germany developed technically sophisticated weapons but could not manufacture them in quantities that affected strategic outcomes. American industrial capacity produced less sophisticated but highly effective equipment in overwhelming numbers. The M4 Sherman was objectively not the best tank of World War II by most technical measures of armor protection, gun power, or mobility. But American factories produced approximately 49,324 of them, compared to approximately 6,132 Panthers. This 8-to-1 production ratio, combined with ammunition improvements like HVAP that reduced the technical performance gap, proved strategically decisive. Numbers mattered, reliability mattered, logistics mattered. Technical superiority in individual vehicle performance could not overcome American advantages in these fundamental areas. Throughout September 20th, German attacks continued with diminished strength but undiminished determination. At 11:30 in the morning, one column of Combat Command A had reached Hampont, and another was advancing toward Dieurs when General Wood radioed that enemy tanks had returned to attack near Aracourt. A task force was immediately ordered back to defend the rear area. Actually, only 8 German tanks were involved, having made a sortie toward the 191st Field Artillery Battalion just as it prepared to displace forward and join the advancing column. This attack was readily handled by the 155mm howitzers, firing high explosive at 1,000 yards range, combined with the appearance of rear-guard tanks and some tank destroyers that allowed none of the German attackers to escape. But Colonel Clark, determined to eliminate any remaining German forces in the area once and for all, led his entire combat command in turning back to conduct a comprehensive sweeping operation. By mid-afternoon, this operation was fully underway with devastating results for remaining German forces. Colonel Abrams assembled a powerful combined arms force consisting of 3 medium tank companies of the 37th Tank Battalion and 2 companies of the 10th Armoured Infantry Battalion near Les Ayes. Supporting artillery adjusted its fire to support this attack while maintaining coverage of other potential German approach routes. The force swept systematically through the area, destroying German tanks, half-tracks, and infantry positions that had survived the previous day's fighting. German forces, already demoralized by heavy losses and failed attacks, offered increasingly disorganized resistance. The transformation in American tank crew confidence between June and September 1944 reflected multiple factors working in combination. Crews that landed in Normandy often felt genuinely apprehensive about facing German armor, particularly Panthers and Tigers, whose reputations preceded them. By September, after months of sustained combat, improved equipment availability, including the 76mm gun, and growing familiarity with specialized ammunition, including HVAP, American tankers approached engagements with dramatically different psychology. This confidence shift had direct tactical consequences that German commanders observed with growing concern. Confident crews fought more aggressively, took calculated risks when opportunities appeared, and exploited tactical advantages created by combined arms coordination. While HVAP ammunition alone did not create this transformation, its availability and proven effectiveness contributed meaningfully to improved American armored force morale and tactical performance. Sherman crews who knew they possessed at least some rounds capable of defeating Panthers frontally at reasonable combat ranges fought with greater determination than crews who believed themselves fundamentally outgunned at all ranges. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The technical details of HVAP penetration capabilities deserve careful examination to understand their tactical significance. The M93 round's tungsten carbide core measured significantly smaller in diameter than the full 76mm bore. This sub-caliber penetrator was surrounded by a lightweight aluminum body that engaged the gun's rifling and provided aerodynamic stability during flight. Upon impact with armor plate, the aluminum body disintegrated, while the dense tungsten core continued forward, concentrating enormous kinetic energy into a very small area. This concentration of energy into a dense, small-diameter penetrator proved far more effective against armor than conventional full-caliber projectiles. The tungsten carbide core, traveling at extremely high velocity, would punch through armor plate by essentially pushing the steel aside through brute force applied to a tiny contact point. The physics were straightforward, but the engineering challenges of producing ammunition that could withstand gun-firing stresses while delivering the penetrator precisely to target were considerable. Testing at Aberdeen Proving Ground throughout summer 1944 validated theoretical penetration calculations under controlled conditions. At 1,000 yards, the M93 could penetrate 160 millimeters of armor at 10 degrees obliquity. This meant the round could defeat the Panther's 100mm turret mantlet with considerable margin for error. Even the 120mm mantlet fitted to later Panther variants remained vulnerable at this range. The glacis plate, being both thicker and more steeply sloped, remained problematic. HVAP rounds striking the glacis at favorable angles might penetrate, but this could not be reliably counted upon. American tactical doctrine adapted to these penetration characteristics by emphasizing that HVAP provided a capability to engage Panthers frontally by targeting the turret mantlet at ranges up to 1,000 yards. This represented a fundamental improvement over standard ammunition that required closing to suicidal ranges under 100 meters. Crews were taught to aim for the mantlet rather than attempting glacis penetrations. Flank shots remained preferable when tactical situations permitted maneuvering, but HVAP provided an option for frontal engagement when flank shots proved impossible. The WWII tests, conducted on August 20, 1944, used captured German tanks to validate HVAP performance under conditions approximating battlefield reality. American engineers positioned a captured Panther and tested various weapons and ammunition types against its armor at measured ranges. The 76mm gun firing M93 HVAP successfully penetrated the Panther's mantlet at 1,000 yards, confirming theoretical calculations with actual test data. These results were immediately distributed to units receiving HVAP ammunition, along with updated guidance on engagement ranges and aiming points. German intelligence eventually learned about HVAP ammunition through battlefield recovery of unexpended rounds and examination of penetrations on knocked-out Panthers. German metallurgists analyzing recovered projectile fragments identified the tungsten carbide cores and understood their significance immediately. Reports documenting these findings circulated through German command channels throughout autumn 1944, but by this point, Germany lacked the industrial capacity to respond effectively. German analysis of HVAP ammunition expressed professional respect for American metallurgical and ballistic engineering, while noting bitterly that Germany could not produce equivalent ammunition in meaningful quantities. German engineers understood the principles perfectly and possessed the scientific knowledge to design comparable rounds. What they lacked was tungsten. Swedish imports that had supplied German war industries earlier in the war had declined to minimal levels by late 1944, as Sweden increasingly recognized Germany's inevitable defeat and sought to preserve future relationships with the likely victors. Domestic German tungsten production remained negligible, despite frantic efforts to locate and exploit any available deposits within German-controlled territory. The tungsten Germany did possess was allocated to highest priority needs: machine tools for aircraft engine manufacturing, armor plate hardening for U-boats and tanks, specialized industrial applications that could not function without tungsten. Producing ammunition that would be fired once and destroyed in the process represented unacceptable luxury given desperate shortages. By late 1944, German tank crews received no tungsten core ammunition for their guns. Standard armor-piercing rounds remained available in varying quantities depending on supply conditions, but specialized high-performance ammunition became essentially unavailable. This asymmetry in ammunition quality added to other asymmetries already favoring American forces: overwhelming numerical superiority, vastly superior logistics, and complete air superiority after Allied fighters achieved air dominance over Europe, massive artillery advantages in both quantity of tubes and ammunition available. The psychological impact on German Panther crews of learning that American tanks could penetrate their armor frontally at extended ranges proved significant and measurable. German after-action reports from autumn 1944 noted increased caution among Panther commanders. greater reluctance to advance across open terrain against American positions, more time spent seeking covered positions before engaging, and generally more defensive mindset when facing American armor. This knowledge made Panther crews demonstrably more cautious, slower to engage, and generally less willing to take tactical risks, even when situations might have favored aggressive action. The strategic implications of HVAP development extended to broader questions about technological competition in modern warfare and the crucial importance of industrial capacity over individual weapons sophistication. Both American and German research establishments possessed highly competent engineers and sophisticated understanding of ballistics, metallurgy, and armor penetration mechanics. Both nations recognized the value of tungsten core ammunition early in the war. Both developed functional designs that worked effectively in testing. The critical difference came down to industrial capacity and resource availability, rather than scientific knowledge or engineering skill. American industry could produce HVAP in quantities sufficient to influence battlefield outcomes meaningfully, though never enough to fully equip all units as tactical commanders desired. German industry could barely produce enough to conduct laboratory testing and evaluate captured enemy ammunition. This pattern repeated across numerous weapon systems throughout the war in every theater of operations. Germany developed sophisticated and often technically superior weapons, but could not produce them in quantities that affected strategic outcomes. American industrial capacity produced equipment that was sometimes less sophisticated by pure technical measures, but highly effective and manufactured in overwhelming numbers that made the difference in sustained combat operations. The post-war careers of veterans who fought at Aracourt reflected the enduring impact of these combat experiences on military thinking and doctrine development. Lieutenant Colonel Creighton Abrams, who commanded the 37th Tank Battalion at Aracourt with distinction that earned him multiple decorations, rose through Army ranks to become United States Army Chief of Staff. He gave his name to the M1 Abrams main battle tank that entered service in the 1980s and remains America's primary main battle tank today. The lessons Abrams learned at Aracourt about combined arms warfare, the critical importance of crew training and morale, and the absolute necessity of adequate ammunition influenced his entire career and the doctrine he helped develop as senior leader. The M1 Abrams was deliberately designed with a powerful 120mm smoothbore gun and sophisticated ammunition types, including depleted uranium penetrators that serve functionally the same role HVAP served in World War II. Modern armor-piercing ammunition uses tungsten alloy or depleted uranium cores for essentially the same density and hardness properties that made tungsten carbide effective in 1944. The underlying principle remains constant across 8 decades. Concentrate maximum kinetic energy into the smallest possible, extremely dense projectile moving at the highest achievable velocity. Modern tank ammunition represents the direct technological descendant of World War II HVAP development. German veterans of Panther units who survived the war and later joined the West German Bundeswehr brought different but equally important lessons shaped by their experiences. They had personally experienced the limitations of possessing technological superiority without the industrial base and logistics infrastructure needed to support and sustain that superiority in prolonged operations. Bundeswehr armor doctrine during the Cold War emphasized quality and superior training, while explicitly recognizing that West Germany could never match Soviet numerical superiority in tanks and other armored vehicles. But Bundeswehr planners, informed directly by wartime experience fighting against enemies with superior resources, also emphasized ammunition effectiveness and crew training as force multipliers that could partially offset numerical disadvantages. The Leopard 1 and later Leopard 2 main battle tanks developed by West Germany used sophisticated ammunition designs, informed explicitly by the realization that ammunition technology and crew training quality mattered as much as armor and thickness or gun caliber. These lessons, learned at terrible cost in places like Aracourt, directly shaped post-war German military thinking and equipment development. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.